neither that would have been good, right? Even this. Okay, so yeah. Take away the responsibility of additional responsibility of managing data centers away from the customers by offering compute as a service. That's where the cloud was born, right? So as part of this transition, what consciously or unconsciously happened is, in the past, when in the era of mainframes, all of computing was happening in one place. Like, think of it as a server room where mainframe was in a massive data center, and all applications are hosted there, whether it's your app tier or your middleware tier, right, or the web tier or your database. Everything was in one place. So speed of light was a different kind of an issue at the time. I don't know if you guys are familiar with CPU affinity as a terminology, as a word. CPU affinity used to be an issue where a transaction, if it is distributed across too many CPUs, you'll run into the speed of light issue, where one core may complete the transaction before the others, and then it'll go into some race conditions, right? So that's mainframe and parallel processing, right? And with mid-range, people started having multiple data centers, right? They could be geographically in a shorter distance or a longer distance. That introduced the need for bigger bandwidth circuits. The LANs and WANs need to be more robust. With cloud, that problem started exasperating, right? If you are a multi-cloud shop, you are now dealing with dozens of regions of cloud, right, where your compute is distributed, and your application could be in any of the compute zones, right? So that created problems with latency, where your transaction time could take longer, and if your application is super sensitive to latency, then it is creating different kinds of issues, right? So the need for connectivity gained a lot of emphasis. So if you think about what is happening today, right? I painted the picture like this because if a provider, if you are a service provider, you fall in the provider category, and any consumer or a payer, I'm trying to blurry the lines between payer and a consumer. Although in the insurance and healthcare industry, it's seen as a different thing. Think of payer as a consumer, right? So as a consumer, we have certain computing that are happening in our place. If you're a .com app user, right, your phone is a compute device. Think of it as an edge device. And if you're from the provider side, think of, in the healthcare industry, think of you as a doctor doing a virtual care, right? So the doctor, he or she, has another device through which they are interacting with you. So that's another computing. And to fulfill the transaction between the consumer and the provider, there is many other layers of compute zones that come into picture. All right. And those compute zones, if you apply that logic of how scales are how hyperscalers are coming in, these big blue circles, think of them as cloud regions, right? It could be the Azure or Google, any of each of them is regions. And then customer, as a provider, you may have your own data centers too, right? Your own data centers, and some of those data centers are fully owned by you, or some of them may be colo. Maybe you are leasing a facility from somebody like AT&T or Equinix or some of them, right? Those. And then today, because of the massive computing needs that are happening, the emphasis for edge computing is also becoming more and more prominent, where you need compute closer to the consumer, right? So those are, big circles are massive regions, provider computes are small regions, and edge computes are smaller, right? So that's how it is. And all of these need to be connected with a highly reliable connectivity so that the transaction can happen, seamlessly. Now, when you switching to connectivity, right? What are the different types of connectivities? I just listed a few examples of the terminologies that we all are familiar with. LAN, local area network. If the two computers in this facility are talking to each other, that's a LAN, right? If two computers within this facility and another DoubleTree hotel facility are talking, the transaction is happening on a WAN, right? The connectivity is happening through wide area network. And if it is on internet, it's a public network. If it's DoubleTree's own network, it's a private network. There's a difference, right? Private networks are considered to be more secure. For a business, there's always a preference for private networks. And some of the other things are physical medium, right? So right now, all our laptops are connected using Wi-Fi, right? But 2 DoubleTree hotels may not be connected using Wi-Fi. They may be using MPLS lines or some other type of WAN circuitry, right? Fiber connections or something like that. There are different types of physical connectivity. The trend, if you are all followers of technology, there's also Starlinks, which is satellite-based connectivity. If Verizon Fios is a public internet, but it's still fiber-based connectivity, right? And then there's devices, because if it's Wi-Fi, there's a Wi-Fi router somewhere, and that's connected to another core router, right? And then there may be switching happening, switching devices. And if it's a private business, you want to protect them with firewalls. That's another layer of devices that come into picture. And inside those, there are some network protocols, right? You probably heard about TCP/IP, which different protocols happen, right? If the connectivity is enabled on a WAN, there's different types of protocols, right? BGP, EIGRP, IGRP, those are different types of protocols. If it is happening within the LAN, there's different types of protocols, right? So there are different types of things, at each layer that happens. If you're familiar with OSI layers, 7 layers, right? Each of these will come into play. Okay. So when you're building a solution for an organization, these are the connectivity, building blocks that each of these technology parameters needs to be taken into account. I'm not going to read through everything, but I'll just emphasize, right? Range. We just talked about WAN, right? If it's between 2 facilities, if your compute zones are geographically, distant, then the range means what is the distance between them two, right? If it's too far apart, WAN technologies will come into picture. If it's within a facility, then a LAN will work, right? Throughput is how much bandwidth is available between the two compute zones, right? What is the performance, right? What is the latency, resiliency, flexibility needs, right? That's a performance, right? And then the security of it, right? Because security has to be integral to everything it's done, right? Does it support authentication when somebody's accessing a network? Is that access authenticated, right? And when the packet is traveling on the network, is it encrypted, right? So does the technology provide options for you to encrypt that, right? And the strength, right? Meaning, this is where I'm gonna touch a sensitive topic between academicians and the industry. When the industry wants to adopt it, when they're selling a product, they commit to certain SLAs and SLOs. So it has to be 100%. 90%, 80% usually don't work, right? I think the maximum they'll accept is like 99.9, something like that, right? Those are the reliabilities that they look for on any technology. So that's why we partner with big enterprises, partner with companies who has the reputation to deliver and adhere to their SLAs, right? That's why big companies starts doing with business like with Amazon, AWS, and Google. Oracle is a good cloud too. IBM is a good cloud, but they are not the top because they are still getting there. There's still the maturity is still happening with them, right? Those are the factors you take into account, when you're driving strategy of an enterprise, and the maturity of these technologies too, right? Somebody talked about BigQuery. I think somebody was taking an example, right? It was JP here who was there, right? BigQuery is a service. At an enterprise, you still have to take into account its disaster recovery scenarios. I don't know if some of you know, it's only available in one region throughout US. Yes, it's a globally accessible API, but it's only available in US Central. They're still working on making it omni-region available, but these things need to be taken into account. The maturity of those diverse, but so each irrespective of where your application is, you'll need to give the flexibility so that your application can reside in any compute zone by making the connectivity layer seamless to the customer. Now, that's an ideal goal to have. And what I mean by that is, right, so if you think of each of these entities that you're seeing on the screen as a computing zone, any to any should have a best possible connection, right? Meaning the payer should be able to talk to a hyperscaler or a provider compute or near edge compute or the provider too, right? Vice versa. All these things should have a seamless connectivity. It's easier said than done. That's the message I want to send out here, right? And that's, that's made that makes my job fun, because it's easier said than done, meaning we take it for granted when we enter here, we want Wi-Fi, okay? Because somebody else took care of it. What does it cost for them to take care of that? Yes, it's a service that we are providing because that's part of the business, and they're transferring that cost to us through different forms, right? Similarly, in business, to make this possible, that infrastructure needs to be set up, right? And especially when you are in a retail business, right? If it's a consumer-facing application, all these factors are going to play a significant role. And the medium you use and the application designs also inherently, have certain expectations on this infrastructure, right? So, this is something that, it's not seamlessly available because somebody else, we feel that it is seamlessly available because somebody else behind the scenes, if you're an infrastructure guy, you'll know this, but if you're an application guy, you probably take it for granted this needs to exist, but somebody needs to do the work behind the scenes. Now, in addition to having the connectivity, security also needs to be built into these things, right? Especially since the cloud, right? Network is no longer the boundary, right? As with the explosion of the cloud, ever since the cloud was introduced, network is no longer our boundary. In the past, right? Because all your applications were hosted in a data center, and that data center is the walls that you own, right? You are able to put building security around it and say, I know who's coming in, who's getting out, and I can trace every packet within because it's my own. Security was relatively easier. But with cloud, the data and the packet is no longer within your walls. So the approach for security is much more stringent now, meaning you have to take it into account like at every aspect of it, right? And especially based on the business you are in, right? So that's why I say, you got to say for security and compliance should be, define, build, and defend your walls. First, you need to define your walls, because with cloud, your walls have changed. So you got to define what your walls are, and then build to make sure that you have the ability to protect those walls, and then you also defend those walls through different technologies, right? So what is defining? How do you define your walls? These are through compliance, right? Your business has legal requirements, your government regulations you deal with, you have a business requirements, and some businesses have their own special requirements based on type of business they are in. Like, if you are a healthcare business, you deal with something called RDC, where you have contractual obligations with your customer, right? And there's also ethical compliance. As a business, you set your own rules around how do I want to do business, right? So there's that. And in security, if you take the security aspects of it, right, identity and access management, data protection, and a strong encryption, and then you have to have cyber defense to it, meaning just protecting me doesn't mean that you're safe. Even if somebody breaks the protection, you have to have mitigation mechanism, the defense mechanism to quickly remediate those things, right? And all of this has to be continuously governed, like continuous governance on top of these things. Another way to show that is, right, all of these compute assets needs to be constantly, secured and monitored for security reasons. So this is what a view that I shared, right? Now, the message I wanted to convey here is, right, if you're a solution architect, whether it's on the data side or a e-commerce side, what you should be sensitive about is when you're designing an application, connectivity cannot be taken for granted. It has to be thought through. When you're designing an application for an end-to-end business application, think of it that way. From a consumer to the provider, there is many layers of computing that is happening, and that computing is connected to, okay? And based on how you architect your applications, if your compute needs are closer to the consumer, where these days there's a lot of edge computing that is happening. I think somebody covered MEC2. That's one of the areas I'm actively exploring, managed edge computing, right? If you decide to deploy one of the application layers in the near edge compute, connectivity from the device to the near edge compute could be super expensive. Okay, so that can quickly change the dynamics around total product cost. So those things need to be fully thought through, and you got to be sensitive about those things, and especially if you have a I think that today, these days, right? I was talking to some of the industry experts in this area, like the telcos. 20 milliseconds, yes, there is a solution. Yeah, it's still so expensive that you have to sell an arm and a leg to accomplish that. But if your design expecting lesser than that, something like 5 to 10 milliseconds, it's crazy expensive. It's possible, technology is there, but you may never be able to break even if you decide to go forward and invest in such an infrastructure to make it available, right? Those your expectations on network SLAs could be making a breaking point for your product success. So be sensitive about those things, and the best part in being in the IEEE Cloud Summit and listening to some of the keynote speakers, distinguished speakers, is the work that is happening in the academia that about optimizing how computing is done itself. Plus, I think tomorrow at 9 o'clock, Dr. Jing is going to talk about how to optimize your connectivity too. I think, and those things are gonna decide the future. Research like that is going to decide the future and help the industry, technology partners to come up with solutions to make it more financially practical. So it's it's an exciting space. It's evolving. It's not fully matured yet, but whatever is there today is still workable. So any questions? Yes, gentlemen.
I think you mentioned about the BigQuery only working in one region. I know BigQuery data-wise is support multi-region.
Yes.
Right, in US, you have like 3 different regions.
Right.
Are you referring to one region, or are you referring to something like a compute?
The BigQuery, right? There's 2 components to it, right? Although they are physically closer, the BigQuery equipment is Google custom designed equipment, and that API, the core API in the backbone, resides only in Central right now.
You mean the compute engine?
The compute engine.
Compute engine only in.
Yes. Yep. So any query that you are making today is actually going on the Google backbone to Central, but the data that it is accessing, you could replicate that right now. The BigQuery storage.
That's like a cross region, basically.
Yes.
The data resides in, let's say, West and East, and your compute engine resides in Central region.
Yes.
It's cross region, and then do computing.
Yep.
But it seems like nobody complains. Sounds like there's any issues. That's interesting.
They are able to do that because this is where the fun part, right? One of the fun facts of working in this space is, right, Google, I don't know if you watch the space for announcements about the investments. In the last 10 years, Google invested close to $30 billion in expanding their backbone capabilities. Microsoft did the same too, right? Whether it's the some submarine cables, undersea cables, or that's for the geographical, but within the country too, they've invested significant amount to strengthen the backbone so that customer would not feel it, right? Now, I don't know if you
Yeah, it's a petabytes of
Yeah.
network
yes.
between the compute and data.
Right. So I mean, I did hear people complaining about it, especially in the domain I work with. I don't know if you work with Jason Worry. He actually started talking about how this is going to lead to some issues internally.
Jason worries concerned is because people are saying Google has a new feature is going to come out down the road. It's like a multi-region compute for BigQuery, but right now it's still not there yet. So it will give you what is called disaster recovery, like within 15 minutes, like 20 minutes.
Yeah.
So can satisfy your
RTO, RPO objectives. Yeah.
RPO.
Yeah, I was talking to Keith about this. He mentioned that they are it's not public information yet. They're gonna do a preview on the alternate regions of BigQuery too, right? It's not they already are working on a second alternate offering, right? It's no longer be based on just US Central. So there's going to be another layer through which they are going to serve BigQuery.
Like East and West.
I those details are not out yet, right? Yeah. So
thank you.
Sure. Any other questions? All right. Thank you.
Okay, that's the end of this today's conference. Thank you for your coming and see you tomorrow.
See you.
See you.